Hello friends, welcome back to STM32 Tutorials. I am Ajinkya and we are here to learn the embedded system on STM32 controller. So let's begin. In this video, we will see how to interface LCD with STM32. So how does it work? The liquid crystals have several layers such as mirror, glass filter, negative electrode, liquid crystal layer, positive electrode, glass filter, glass cover. So these are 7 layers that are mentioned here. The LCD that we see in the embedded system are of reflective type. When the liquid crystals are not charged, the light gets reflected from the surface and we consider that there is nothing. When the liquid crystals are charged, the light does not get reflected and we see it as a black dot. So combination of these dots make a character on the display. Different types of LCDs. So there are several types, among which the 16:2, 20:4 and graphical LCDs are very popular. We will see working on a 20:4 alphanumeric LCD. So what does 20:4 means? 20:4 indicates that there are 20 characters per line. Such 4 lines exist on the LCD. So total 80 characters can be displayed on the LCD. To display each character, a 5:8 dot matrix is used. A 5:7 dot matrix is used for character display and the 8th line is used for cursor display. So as you can see, using the combination of dots, we have displayed 1, 2, 3. Now let's see the LCD interface circuit. The alphanumeric display have total 16 pins for the connection with the controller. The total 16 pins are mentioned here, out of which first pin is ground, second pin is connected to VCC, third pin will be connected to VEE for changing the contrast of the LCD. The 3 pins RS, RW and enable are the control pins. The 8 pins D0 to D7 are the data pins and the remaining 2 pins are for the backlight LED. So as you can see, I have connected LCD with STM controller. The D0 to D7 pins are connected to PA0 to PA7, the RS is connected to PA8 and enable is connected to PA9. The read-write pin of the LCD is connected to ground pin as we are going to use only the write functionality. I have connected a pull-up resistor bank which is connected to data pins of the LCD and a small voltage divider is connected. The output of the voltage divider is given to the VEE pin of the LCD. This will set the contrast to a fixed level. Now let's open STM32 CubeMX. The CubeMX software is required to set the GPIO functionalities of the STM controller. I have already set the GPIO functionalities of the controller. So PA0 to PA7 are set to GPIO output and PA8 and PA9 are also set to GPIO output. Now we will go to clock configuration. We have not made any changes in the clock configuration. So keeping it to the internal RC oscillator. Now click on the project management tab. Give the project name. Set the directory where you want to save your code. Select the toolchain IDE as MDK ARM and click on generate code. Now open the Kill IDE to edit the code. Once you open the Kill IDE, click on application/users, click on main.c and open the main file. Now go to the main function. So I have already written the code. In the first line, I have declared an 8-bit local variable, that is LCD val. After the GPIO INIT, I have written LCD initialization. This function will initialize the LCD. In the while loop, I have written a small code which contains a for loop and 2 more functions. One is LCD and second one is delay function. In the for loop, we have initialized the LCD val equals to 0. Then we are checking that the variable is below 10 or not. If it is below 10, then we are going to increment it by 1. Inside the for loop, we have written LCD function in which we are passing 2 parameters. First one is the data and second one is the command. After the LCD function, we have written a small delay of 100 milliseconds. Now let's see the LCD initialization function. Inside the LCD initialization function, we have called the LCD function with some instruction in it. So what are these instructions? The LCD manufacturer provides you with the list of instructions. These are the list of instructions that we use for the alphanumeric LCD. So 0x38 is used for setting the LCD in 2 lines 5:7 matrix mode. 0x0c is used for display on cursor off. 0x06 is used for incremental cursor, shift cursor to right. Then 0x01 is used to clear the display screen, and 0x80 is used to set the cursor to the beginning of the first line. Now let's see the LCD function. The LCD function is very small. In the definition of LCD function, we are passing two parameters. First one is data and second one is command. Why command variable is used for? So as you can see, the LCD operates in two modes, that is command and data. When the RS pin is set to 0, the LCD operates in command mode, and when it is set to 1, the LCD operates in data mode. So what does it mean? When RS is equals to 0, the send byte is for the command register, so it is instruction to the LCD. When RS is equals to 1, the send byte is for the data register, meaning that whatever data is sent, it is for the display. Now it is important to note that whenever we send a data or a command to the LCD, we have to provide the enable pulse so that the data or the command will be returned to the respective register. So a high to low enable pulse must be provided after each data byte is sent. Now let's see the LCD function. Now the command variable is assigned to GPIO 8, which is a RS pin. Whenever the command variable is equals to 0, the data is for the command register, and whenever it is equals to 1, the data is for the data register of the LCD. Now we have to set the data pins of the LCD. We are masking the last bit and we are assigning it to the GPIO pin. The masking is done with the value 0x01. To set the different GPIO pins according to the data, we have to shift the data. The data is shifted to the right and then masked with 0x01. After masking, the variable data1 is assigned to the respective GPIO pin. The right shift count for the different GPIO pins will vary according to their positions. After setting the data pins of the LCD, we have to provide an enable pulse. So we provide the enable pulse by setting the GPIO port pin 9, which is connected to enable pulse of the LCD, to logic 1, and then giving some delay, and after that setting the GPIO 9 to the logic 0. So we provide an enable pulse. Now coming to the LCD initialization function, as you can see in the LCD initialization function, we are passing the instructions along with the 0. So it means the data is for the command register. Now coming to while loop. So as you can see, we have passed the data to data register by writing 1 as the second parameter in the LCD function. Now let's build the code. So we have 0 errors in our code. Now let's go to the simulation. Double click on the controller. Load the hex file, click on OK and click on run. So as you can observe that the numbers are displaying on the LCD. Here you can observe that after displaying the numbers on the first line, the numbers are displayed on the third line. This is because the cursor are incremented in such fashion. So as you can observe that on the first line of the LCD, 0 to 9 are displayed twice. So 0 to 9 are 10 characters and these are displayed twice. So total 20 characters on the first line. Same goes with the third line of the LCD. So on the second and fourth line of the LCD, the characters are displayed from 4. If you enjoy the video, click on like, share and subscribe. And don't forget to watch our other videos also.